Hello students, this is part 3 of chapter 4 and we are talking about precipitation reactions. You guys are going to predict what products are formed and determine if you have something aqueous or solid. And so my biggest recommendation for you here is take your time when you are predicting the products. Spend some time identifying the ions present and then decide what new formula is formed by balancing charges. Cation and anion charges have to add up to 0. Okay, let's get started. So a precipitation reaction is when you have two ionic solutions. So notice there are no solids in here. This is like, say, sodium chloride in solution. And you react these, and an anion and a cation from one of each will end up finding each other and forming a solid that's not soluble in water. That insoluble product is called the precipitate. So let's just learn about this by going through an example. You're going to decide, will a precipitation reaction occur upon mixing sodium iodide and lead nitrate? And we're going to find out what that is if there is a precipitation that occurs. Your general strategy is note the ions that are present, and then you're going to identify new cation-anion combos. I'm going to show you what I call the inside-outside method, and you'll write an equation for this. You'll need to use the solubility rules at the end to decide if you do have a solid or something aqueous. So here are the solubility rules. An ionic compound with a group 1A cation, such as lithium, sodium, rubidium, or ammonium, any anion paired with one of these will always be soluble. Soluble means it's dissolved in water, and we also use the term aqueous or AQ. This is the best rule ever, because anytime you see a group 1 or ammonium, bam, aqueous, the easiest. Nitrates, nitrites, and acetates, any of these guys, they're always soluble. These halides here, they're almost always soluble. The exceptions are with mercury, silver, and lead. Those are insoluble, meaning if I had lead bromide or lead iodide, it would be a solid. But sodium bromide or sodium iodide is aqueous. Sulfates are soluble, but there are some exceptions here. Barium sulfate's a solid, for example, silver sulfate, etc. And any other anion I did not mention, assume they're insoluble, unless you have a group 1 cation or ammonia. They're not all insoluble. There are a lot of gray areas, but we're not going to worry about those little exceptions. Okay, so back to our question. Will a precipitation occur when these two guys mix? Pause this and write the formulas for these two, identifying the ions present. So you should have gotten NaI, that's aqueous, and then lead nitrate, that's aqueous, and I didn't write it here. But sodium's a +1, group 1, and it pairs perfectly with the -1 iodide, so those are balanced. Lead is a 2+, that's what the Roman numeral told me. Nitrate's a 1-, so I needed 2 nitrates. So that's your correct formula. Okay, now what? We've identified the ions, and now we're going to make new cation-anion combos. So now the sodium, the cation of this guy, is going to pair with the nitrate, the anion of the other guy, and the lead's going to pair with the iodide. So one thing that you need to know is you always put cation first and anion next. So the way this works is the cation of one pairs with the anion of the other. These are the outside guys. And then the lead and iodide, those are the inside guys. So go ahead and try to do this. Write a new formula for sodium and nitrate combining and lead and iodide combining. And lead, the cation, comes first. So notice what I did. Here's my inside guys. And I recommend doing these lines and writing the cations, lead 2+ and I-. Up here, sodium plus and nitrate minus. Notice I didn't carry the 2. I find that when students don't write the basic ions out, they end up carrying the subscripts, which they don't necessarily need, because sodium and nitrate are already balanced, 1+ and 1-. So if you wrote Na parentheses nitrate 2, that's not correct. So don't get into that habit of doing that. Here, lead's a 2+, and yes, I need 2 I's. So you do have to take your time and figure it out in balance charges. So what you get is lead iodide and sodium nitrate. The other thing you needed to do was make sure the equation is balanced, right? We didn't carry the subscript, but there are 2 nitrates on the left, so there better be 2 nitrates on the right. So I put a big coefficient 2, that gives me 2 sodiums. So I put a big coefficient 2 here, that gives me 2 iodides, and that's nice because I did have 2 iodides on the right. So you make sure the equation is balanced. Sometimes it already is, and you don't have to do extra work. And don't forget to add states of matter. The real question was, will a precipitation reaction occur? You would have looked at the solubility rules, sodium iodide. Normally iodides are soluble, but paired with lead, it's a solid and insoluble in water. All nitrates and also all group 1s are aqueous. Okay, this is what it looks like. This is actually with potassium, not sodium, but potassium iodide and lead nitrate. You have these ions just floating around in solution. It's an aqueous solution, nothing solid. The lead and the nitrate, everything's aqueous. So you can see them here, this clear solution. When you mix them though, look, even as you're dripping down through the liquid, a solid forms, this beautiful yellow precipitate. What does that precipitate? The lead iodide. So you could see here the lead iodide forms this nice, neat, solid array, and any unreacted ions or any spectator ions will be floating around in the solution above. Okay, the last little bit is to just test your knowledge. So I have 2 beakers. Beaker A has a 2- anion and a 1+ cation. I want you guys to tell me out of these, which of these could be dissolved in beaker A. So number 1, it has to be soluble in water. Number 2, it needs to produce a 1+ cation and a 2- anion. So pause and have a think about that. Also do beaker B. Beaker B has a 1- anion and a 2+ cation. So do both and then unpause. So beaker A must be sodium sulfate because sodium's a 1+ and sulfate's a 2-, and it's the only one that can be dissolved. Here it's not KCl because Cl is a 1-. Magnesium bromide, Br is a 1-. And here silver sulfate, that doesn't dissolve in water. So it wouldn't produce this whole beaker of all free-floating ions. Beaker B needs a 2+ cation, so ammonium nitrate is out. That's a 1+ cation. It could be magnesium sulfate, but sulfate's a 2- anion, so it can't be that. Barium nitrate is the answer. And the reason why it's not calcium fluoride is because that's not soluble. Fluoride is not one of the anions mentioned, and it's not paired with a group 1. So then we assume that it's insoluble. Okay, I'm going to end here, and we will continue more with acids and bases next time.